All right, guys, now that you've finished 4.7a, we're going to use handout 4.7b to answer the questions on 4.7c. But before you can answer the questions on 4.7c, I'm going to actually do a demonstration so you can see how this activity is supposed to work, okay? So this is designed to give students a strong understanding of the energetics of breaking and forming bonds, okay, before we do any math calculations, which will happen on Monday, okay? So what we're going to do is we're going to start with our particles, okay? And we're going to have two diatomic red ones that we're going to stick at our molecular level view here, okay? And that's also going to be in my reaction being modeled. I'm going to show that here, right? So I'm going to have two of these, and we're going to break this into its two separate components, okay? And I'm going to show that as I do that. But we're going to start with an initial temperature of 25 degrees. And so what you're going to do is you're going to use these little cutouts here, and each little box represents 100 kilojoules, right? But we're going to start at an initial temperature of 25. Oh my goodness. Okay. Okay. And so that is going to be my initial temperature. So I'm going to mark that here using that cutout. Okay? So this is where we're starting, right? We're going to arrange them in their diatomic molecules. And then now we're going to break the bonds, okay? So bonds being broken. If I break this bond, ooh, that was fun, right? When I break that bond, what ends up happening, right, from our, if you look at the table that's at the front of handout 4.7, it gives you the bond strength, and you'll see that you have the two, let's show that really quickly, right? You've got these two reds. When you break them up, that bond strength is 100 kilojoules per mole. So when I break up that mole, right, that means that took 100 kilojoules to do, and so I'm going to take 100 kilojoules, one of these cubes, away. Ooh, that's fun, right? But I'm not done, right? So I'm going to break the other one. Ready? Okay, so now they're broken, right? And when I do that, I'm going to break. That's going to cause that to go away. I don't have any more to break, right? So then my final temperature is going to be 15, right? It took 100 kilojoules as I broke each of those bonds. Every time you break a bond, right, you have to take the required energy from that solution. The heat has to come from somewhere, just like matter cannot be created or destroyed, energy cannot be created or destroyed. The energy that I use to break those bonds has to come from the solution, and so the solution has to give it to break those bonds, so my temperature is going to decrease, okay? So to absorb energy and to break those bonds, the temperature goes down, okay? All right. Now we're going to do a different one, this time with blue chips, okay? And we're going to make some blue. Let's take these away. We're still going to start with that initial temperature like I had before. Put these back to 25 as my initial temperature. Okay. That's room temperature typically. Not in my room because it's freezing. And here we're going to actually take the blue chips and form a blue bond. Okay, so this is bond formation. And it's going to form a diatomic molecule. Okay. So in my molecular view, I'm going to use my two blues. And so when we start off, they're going to be separate, right? Just like our magnets were separate, this is going to be separate. Okay. So here, this is where I'm starting, right? But when I look at my blue, right? My blue says from my handout 4.7, right, that it costs 200 kilojoules to break that bond because it's a stronger bond, okay? So when I break this bond, it's going to cost 200. But I'm not going to break it this time. I'm going to form it, right? So when I form that bond, bring those together, then I get to gain not just 100, because this bond is worth 200. I get to gain 200. And then my final temperature will go up to 35. So thinking about the formation of the bond, instead of taking 200 kilojoules, gives off 200 kilojoules. And so when it gives off that heat has to go somewhere. That heat's going to go into the solution. And when that heat goes into the solution, when it's being released, you'll see a raise in that temperature, and that temperature will increase. Okay? So I want you just to have a review of our terms that we've used before, way back in Unit 1, endothermic versus exothermic. So remember, endothermic means heat is being absorbed. So in a reaction, especially a fuel reaction, when we have heat being absorbed, that means it's going to feel cold. Now think about fuel, okay? Does it feel cold? Does the temperature go down? Right? Think about the red chips versus the blue chips in this final temperature here. In the blue, right, we brought them together and they had to release energy. Releasing energy, it means it's going to exit, right? That's exothermic. So think about our terms endothermic and exothermic as you complete handout 4.7, questions 1 and 2, and be sure, like I have it here, just take a picture of what you form. You can find your chips and scissors to cut out your paper and all that kind of thing in the craft cabinet in the corner, okay? See you Monday.